Close your eyes for a moment and imagine a young boy sitting alone in a small town in South India. No famous teachers, no advanced textbooks, no formal training in higher mathematics, just a notebook and an obsession with numbers. This was Srinivasa Ramanujan. He was not raised inside elite universities like Cambridge or Oxford. He grew up in Kumbakonam, in a modest family, often struggling financially. As a teenager, he found a book called A Synopsis of Elementary Results in Pure Mathematics by G.S. Carr. It was not a normal textbook. It was mostly a long list of formulas and theorems, thousands of results, with almost no proofs. Most students would find such a book frustrating. Ramanujan found it magical. Instead of asking, "Where is the proof?" he asked, "Why is this true?" And instead of waiting for someone to teach him, he began exploring patterns on his own. He filled notebooks with formulas, identities, infinite series, continued fractions, many of which were completely unknown to the mathematical world. Here is the extraordinary part. He often wrote down results without writing proofs. Not because he was careless, not because he didn't understand rigor, but because, in many cases, he saw the truth of a statement long before he could explain it formally. When he later sent his work to G.H. Hardy at Cambridge, Hardy was stunned. He said that some of the formulas were so deep that they must be true, because no one could have invented them without extraordinary insight. Hardy famously rated mathematicians on a scale of 100. He gave himself 25. He gave Ramanujan 100, but how did Ramanujan know? This is where mathematical intuition enters. Mathematical intuition is not guessing. It is not magic. It is pattern recognition at an extremely deep level. When you spend thousands of hours playing with numbers, manipulating series, transforming expressions, your brain starts seeing structures others cannot see. Think about how a chess grandmaster looks at a board. They don't calculate every possible move. They recognize patterns instantly. Years of exposure compress into a single feeling. This move is right. Ramanujan had that feeling with mathematics, for example. He discovered astonishing formulas, 4-pi formulas so efficient that they are still used today in high-precision computations. He worked with infinite series in ways that seemed almost supernatural. At times, he wrote results that mathematicians proved only decades later. There is even a famous story about the number 1729. When Hardy visited Ramanujan in the hospital, he mentioned that he came in a taxi numbered 1729 and thought it was a dull number. Ramanujan immediately replied, "No, it is a very interesting number. It is the smallest number expressible as the sum of two cubes in two different ways." And he was right. That is, intuition at work. A mind so deeply immersed in numbers that relationships appear instantly. But here is the important lesson. Intuition did not come from nowhere. It came from relentless curiosity, from obsession, from working alone, exploring examples, checking patterns, writing thousands of calculations by hand. His intuition was built on intense practice, and yet intuition alone was not enough. When Ramanujan went to Cambridge, Hardy insisted on rigorous proofs. Many of Ramanujan's results needed to be justified formally. Some were slightly incorrect. A few were incomplete. Intuition gave direction. Proof gave certainty. This balance is the real power of mathematics. When should you trust your gut? Trust your intuition when it guides exploration, when it suggests a pattern, when it whispers, "There is something here." But do not stop there. Intuition is the compass. Proof is the map. Without intuition, mathematics becomes mechanical. Without proof, it becomes unreliable. Ramanujan reminds us that great discoveries often begin with a feeling, a deep sense that something is true, even before we can explain why. So the next time you solve a problem and you feel that sudden clarity, that sense of this must be right, pause. Ask yourself, is this intuition built on understanding, or is it just a guess? If it is built on deep engagement, on patterns you've studied, on concepts you truly understand, then trust it, and then prove it. Because mathematics is not just logic. It is insight guided by discipline. Ramanujan did not magically know theorems. He trained his mind so intensely that truth felt familiar. That is the power of mathematical intuition. And maybe, just maybe, the more you immerse yourself in patterns, the more your own intuition will begin to speak. Asterisk if you enjoy deep mathematical stories like this, where history, intuition, and real insight come together. Make sure you subscribe to the channel, like this video, and share it with someone who loves mathematics as much as you do. This is just the beginning of our new season. More powerful mathematical stories are coming. Stay curious, stay consistent, and I'll see you in the next episode.